Toro, Senior Communications Manager for Turntide Technologies. Thank you for joining us today to learn more about the value of working with a strong applications engineering team. We are thrilled to have Associate Director, Global Product Applications Engineering, Johnny Hyde, presenting for us this morning. Thanks so much for doing this with us, Johnny.
No worries, Laurie.
Before we get started, we have housekeeping tips to share. This presentation is being recorded and will be available on demand on the Current and Wave website. We will be taking questions at the end of the presentation, so please use the Q&A section, not the chat section, to ask your questions anytime during the webinar, and we will answer as many as possible. You'll also see in the chat a link to register for the August webinar on hybrid rail solutions for the next era of electrified mobility. Feel free to register for that one. And remember, this event is live, so when we mess up, and we might, laugh with us, and remember we're live too. That's it for housekeeping. I am going to share my screen and get the presentation up for everybody. So give me 1 minute. And you're going to see both of us for a second, but not for long. So hopefully you guys are seeing my screen, and Johnny, you can just let me know when to move forward.
Grand. Thanks very much, Laurie, and thanks everyone for taking the time to join us today. My name, as Laurie said, is Johnny Hyde, and I'm the Associate Director for Product Applications at Turntide. I think so. Before we make a proper start, I want to kind of directly address the title of the webinar, the value of working with a strong applications team, and kind of almost answer that straight away and say it's pretty obvious and non-controversial that the value really is an increased chance of success in the application. So I think whether you're a customer, a technology partner, you know, we can all be agreed that that's really what we're trying to do in applications. So I guess the real question is, how do we add that value, or how does the team add that value? And I'd like to kind of briefly set out what I hope you can sort of take away from today's session. I think by the end of it, you should have a good understanding of sort of my views on applications, my philosophy, my mindset. And you can probably take it as a given anything that I'm talking about sort of generally or conceptually has kind of made its way into the way that we do applications engineering at Turntide. I'll also share some kind of practical examples at the end of the webinar, which kind of are couched in kind of examples at each of the customer sort of journey stages. And how the applications team kind of bring the concepts, the values, the principles, the process together in a kind of practical way, and add the value for customers on the actual project. So I think it's worth maybe just as well talk a little bit about what applications engineering means, because that can mean different things in different organizations. And I've over the years seen lots of different flavors of that, whether it's sales engineering, kind of just giving basic product capability answers to customers, or whether that's field applications, who are that kind of front line of technical support in the field, or kind of the interface between an organization and the customer, all the way through to what we call at Turntide product applications engineering, which is kind of where we provide that additional technical depth that's required for very bespoke solutions and more tricky applications. And I'd say that at Turntide, the applications function really spans that the full spectrum of those different elements. So I think a legitimate question someone might ask at this stage is, why should you listen to me on this subject? And I think I'd like to kind of just share a little bit about my background and what's kind of shaped my perspective on the subject. So I've been in electrification for around about 15 years now, in loads of different roles in product development and testing, test and validation, spent some time early on in my career actually as an applications engineer, but really spent most of my sort of technical background, about half of that 15 years, as a motor control engineer, working on all things, you know, inverter integration, motor characterization, and kind of making contributions to our motor control algorithms. And I'd say the bottom line is, as sad as it might be, I'm genuinely passionate about applications engineering and customers succeeding with the product. And I think you'll see through some of the slides later on just how important I think the kind of people element is. So I think we'll start by just sketching out the basic questions that all customers ask, or in my kind of view, should ask. They're really, really simple. They may seem trivial, but I think that's where it all starts, to really add the value for customers and help them succeed. Next slide, please, Laurie. So yeah, pretty non-controversial questions, like I say, regardless of the application type, whether it's a vehicle, a machine, industrial, agricultural, whether it's a power generation application. I think these are the questions, the really high-level questions that always apply. Am I choosing the right product? Will it work in my system? Can I deploy it successfully? And then kind of really a question of with a slightly different flavor, have I missed anything? And I'd say really the role of the applications team isn't really to explicitly or directly answer these questions. It's really to kind of, I would say, reshape the questions in terms of what, you know, leveraging our experience and kind of domain knowledge to make sure that we're actually asking the right questions. And I think a couple of examples of that are, we take the first question, am I choosing the right product? My question back to the customer is, well, which problems are you trying to solve? Second question, will it work in my system? Well, what does the system look like? What are the must-haves, and where can kind of performance operational compromises be made? And ultimately, I think these questions are just expressions of concerns that customers have about uncertainty, risk, and ultimately whether they're going to be able to succeed. First three questions are pretty tangible. They're kind of very much sort of mapped onto the process stages of product selection, product integration, product commissioning. But the last one is a little bit different, and that really points to the kind of system level thinking mindset that we prioritized at Turntide, which I think is of paramount importance, because really the diversity of applications and customers we see is really, really broad. So you'll notice, I hope, in each one of the boxes, you'll see the word confidence, and that's kind of by design. We'd all like to have complete certainty about things and have a very rigorous and scientific approach. My view is that the best way to kind of handle ambiguity and uncertainty is to make sure that we're kind of building confidence in the end outcome as we go through the stages, or as we sort of tackle what the customer wants in terms of the end game. So I think the goal isn't really to eliminate every uncertainty. It's really to just build the confidence throughout the application. So whether, you know, you're selecting a product or defining an integration strategy, or you know, challenging your own assumptions, that system level thinking is really, really critical. And I think the objective is always the same: increasing confidence in the eventual outcome. Next slide, please, Laurie. So yeah, we're going to start kind of breaking that apart a little bit and say what are the kind of broad areas that you've got to get right before we get into the kind of process, the people, and the principles. And I've defined these kind of three sort of broad areas that I think really help build confidence of decisions, planning, and ultimately judgment. Where does the confidence come from? I think it comes from taking care of these sort of broad areas and having a disciplined engineering approach. You know, confidence is not the same thing as optimism, and I've seen these two things kind of mixed up a little bit in the past. We've done this before, so you make a load of assumptions and then something sort of catches you out, you know, in the field. And ultimately success, in my experience, is rarely accidental and always sort of carefully managed. If we dig a little bit into decisions and kind of what I mean by that, good decisions really start with being sure that we're solving the right problems and asking the right questions in the first place. Customers often arrive with us with kind of a preconceived idea of what the solution might look like, or actually a kind of product in mind. And then when we do an exploration of the full system, you know, we see that actually there are some kind of subtleties to the questions that you should actually be answering at the front end. And I've got a kind of couple of examples here to kind of illustrate this. So a customer might pick a piece of power electronics based on the performance kind of metrics on the data sheet, but once we kind of have a careful look at the system, it's clear that something else in the system is actually constraining the ability to get the full performance out of that product, and that allows us to kind of optimize that, maybe give a lower cost solution, or you know, have a simpler implementation. Another one is, you know, products at A and B sample of kind of maturity often have kind of known limitations, which is quite normal for early samples at kind of at that early maturity level. But if we kind of understand the limitations with respect to what the customer needs and when, kind of earlier delivery of the product can often be made. So in this area, applications engineers really sort of there to help customers deal with the ambiguities, sort through the kind of assumptions and unknowns, and help them make informed choices. Then on to planning, and that's really about anticipating risks before they become issues. And I'd say without really careful planning at the front end, issues that kind of surface later on, you've just got way more limitations in terms of plan Bs and plan Cs to take account of that. So having a real good plan and kind of analysing the interfaces and understanding the full system as early as possible in terms of, you know, packaging constraints, AMC, cable routing, installation requirements. You know, if you identify those things early, any risks can be understood and kind of managed a lot more successfully. And I think strong planning really creates confidence that you're not going to uncover anything kind of unpleasant at a late stage. And then lastly, judgment, which is really kind of, I would say, related to the system level thinking that I referred to, which is kind of balancing product, system and application considerations. Engineering decisions are, as everyone knows, really sort of black and white, and usually there are kind of trade-offs to be made in terms of performance and cost and complexity, robustness, and risk. Example here would be, you might deliberately over-specify some power electronics to give additional thermal margin or performance margin, and from a kind of product perspective, that can look like it's non-optimal. But from a system perspective, the reduction in risk can kind of justify, you know, having something that, you know, doesn't always make sense if looked at that sort of narrow sort of product level. And I think this is really where experience and system level thinking become really super important. Good judgment means really understanding where the compromises should be made and which are the kind of customer outcomes the customer kind of prioritizes the most. Let's say if confidence is built through decisions, planning and judgment, I'd say the next question becomes, well, what enables a good, strong applications team to kind of consistently make good decisions, plan effectively, and apply that judgment? And I think that's where the foundations of a strong team really come in, and we're going to talk a little bit about principles, process, and people, and kind of dig down into some specifics. Next slide, please, Laurie. So yeah, three pillars of a real strong applications team, in my view, are principles, where, really tells you how the team thinks, which outcomes they're accountable for, process, which gives the structure to make that repeatable and predictable and consistent for all customers. And then ultimately the people, which is really about the capability of the individuals on the team. I'll say a few times in the next few slides that no amount of carefully defined process and well-intentioned principles is actually going to deliver for customers. Ultimately, it is people who kind of bring all that together and kind of breathe fire into it to actually deliver. Next slide, please, Laurie. So, yeah, principles. So just quickly kind of rattle these off, and then we'll kind of do a little bit of a dive into exactly what I'm talking about. So, customer success first, absolute laser focus on customer outcomes. It seems like a slogan, it seems really obvious, but when you're a supplier of the type that Turntide are, you just do not succeed unless your customers succeed. So applications teams should be, and certainly my applications team is absolutely laser focused on those sort of customer outcomes. Secondly, solution focused, not product focused. I've kind of sketched that out a little bit in terms of kind of system level thinking, and that's basically the kind of the next point. Issues often emerge at the interfaces between the parts, and in my experience, that's where I've seen a lot of things overlooked and ultimately kind of lead to issues in the field. And then cross-functional coordination, which is an admission that the apps team is not solely responsible for delivering a successful application, but we are at a really good vantage point to kind of bring teams together within a business and then make sure that the customer isn't left joining the dots themselves between engineering and quality and operations. Next slide, please, Laurie. So yeah, process. First thing I'd say is if you're putting an applications team together, definitely have a process. You can kind of get away with it with a certain sort of narrow customer base, but if your business is succeeding and as your customer base is kind of growing and getting more broad, having a process that allows you to kind of leverage the team capability for all application types and all customers is absolutely paramount. And a kind of word of caution. I think when people hear process, they think bureaucracy, paperwork, things going slowly, gates for kind of gates' sake, and that's very definitely not what I mean. I think what I mean by process is simply a clearly mapped out set of stages with checkpoints and reviews that really effectively sort of help us drive projects end to end. And I think the kind of what I've defined in the slide here really maps onto the kind of stages of the customer journey that I'll get onto in a little while. So define early will be product selection, integrate deliberately, obviously integration, validate in the real world. That's what I would call commissioning or physical sort of deployment, physical installation. And then I think really critically look beyond sort of basic performance criteria. I'd say the first three are broadly kind of aligned to pretty well understood V model sort of thinking, and it's nothing controversial in the process. That's known to work, and certainly at Turntide, that's kind of basically the kind of model that we follow. So why really have a process? Again, consistency, repeatability, and reliability. Applications teams support loads of different customers with sort of different needs, loads of different types of applications. And as well, the members of the applications team can have really diverse backgrounds. And at the end of the day, those sort of differences are a real strength. But without I suppose a structure in place, the outcomes can become a little bit variable in terms of kind of who works on what. A good process should really sort of leverage that individual experience and knowledge across the full team. Because at one end you've got customers who are going to do an electrification project for the first time, and at the other end of the spectrum you've got OEMs who are maybe expanding an existing platform. And I think both types of customers should expect to get the same quality of engineering support and the same sort of structured approach. So the last sort of point there, look beyond basic performance criteria. I think this is an area where I think this is kind of basically overlooked quite a lot. Pretty easy to focus on the top level performance metrics in electrification of voltage, current, speed, power, torque. But I think a good process should kind of force the team to consider those kind of real world operating conditions like ingress protection, vibration, EMI, thermal, environment, duty cycle, driveline oscillation, all of the the interface stuff. Often these are the factors that actually will determine success or failure in the field. So principles tell us how we think, and process provides the framework of how we work. Obviously, like I said before, it's ultimately people who kind of bring that to bear in terms of helping customers succeed. Having the right team is absolutely sort of critical. The range of products and applications and associated integration challenges and potential issues dictate a team with a pretty deep and varied sort of background. Whilst sales engineering is a really important of applications engineering, it's a really important element of the way we do applications engineering at Turntide. The complexity of a lot of the electrification projects that we work on demands a team of engineers who've really lived through deployment and testing and validation and all of the the challenges that come along. And I think it's really that experience which helps bridge the gap between what the customer needs and the kind of engineering realities out in the world. So what does kind of capability look like? Given the diversity of the applications we support, certainly at Turntide, we've deliberately built a team with a real mix of backgrounds of kind of quality, test and validation, and a lot of the stuff that I kind of sketched out in terms of my journey. It's really about having engineers with real world experience, product knowledge, domain knowledge, systems knowledge, and practical integration and commissioning experience. So can speak your language. That's a kind of proxy really for good, I would say, for good communication. Absolutely imperative that a good applications team listens to the customer. Customers, in my view, don't really care about, if you've got the power electronics knowledge, motor control, machine knowledge. What they care about is, someone who understands what they're actually trying to do. And often, the apps team kind of leverage our connections internally to quality and engineering to kind of, to get that really deep understanding. So a lot of the time, it's just about listening to what the customer needs. And yeah, the apps engineer should really care and be effectively the advocate for the customer internally in an organisation. And I think to a large extent, the role really is about just helping customers achieve what they're trying to achieve. Yeah, so the last one's a bit soft, a bit woolly, but being someone who's kind of been tasked to build a team, I would say strong values and character are perhaps the most important part of the kind of people puzzle. Apps have a lot of constraints put on them, whether that's from customers or sales, and you're really at that kind of pivot point of kind of looking out into the world on the commercial side, and then trying to kind of mediate that internally. And yeah, customers should expect a sort of clear point of contact, but they should also have the confidence that, you know, the broader product knowledge of the and domain expertise of the business is being leveraged, and I think that's really communication skills of the apps team come in. So what does all this look like in a sort of typical customer project? Next slide, please, Laurie. So yeah, obviously there are a lot more sort of stages and checkpoints, etc., involved in a customer journey, but I've kind of boiled that down to what I think is 4 really important key milestones or stages of product selection, where get that right first time, product integration, anticipate and avoid deployment issues, product commissioning, prove as much of the functionality in the field as you can, and then obviously in service support, troubleshoot any issues that do get through and kind of deliver long-term support to the customer as they, you know, move into production. So yeah, like I said, whilst the full journey does include a lot more detail, I think these are the real pivotal stages where we can kind of remove as much risk and build that confidence that I spoke about earlier. So the quality of the product selection directly affects integration. The quality of the integration directly affects the sort of success of the commissioning, and then commissioning largely determines the nature of the issues that you actually see in the field. And one of the things I've learned over the years is just how quickly risk can compound if it's not sort of addressed early or when things first come to light. You know, issues that come to light now just end up as kind of system constraints and performance compromises later, which, you know, you really want to address as early as you can. So like, you know, you can have a plan in place to overcome that. And luckily, in the same way that risk kind of compounds, I would say confidence does as well. So when the requirements are understood precisely, and the integration challenges are anticipated and the performance is validated in the real application, deployment tends to be significantly smoother. And at that point, usually in-service issues are quality or sort of product issues. So we're going to go through each stage now, and I'm going to give a few examples of kind of what the applications team does, and kind of brings a lot of the, you know, the concepts and the ideas that I've kind of rattled through, and how we kind of leverage that for real customers and real challenges. Yeah, so yeah, product selection. So I'm going to break product selection down a little bit. So that really starts with application scope and getting a broad idea of the application, and then move on to a more kind of comprehensive gathering and exploration of the requirements, and then do a technical assessment on those requirements and start moving towards a product recommendation. And then we've got, you know, enough confidence that the requirements are met, we'll typically, you know, make a product recommendation to the customer, and kind of lay out the trade-offs if there's a number of options there, and kind of come up with a formal offer. So the example I've chosen here was we worked with a customer who was putting a recreational vehicle together, and they had some pretty hard requirements for very high acceleration, kind of off the mark, and they also had some pretty hard requirements in terms of top speed. Anyone who kind of, you know, has been involved in inverter integration, electric machines, know that these two requirements often clash in terms of a given system voltage. So what we've done with this customer, we're able to take their sort of high level system level vehicle requirements and kind of break them down into a number of different gearbox options, a number of different electric machine options, and inverter options. And eventually we're able to kind of put something you know, together in terms of them three elements that did actually satisfy the two pretty demanding and diverse requirements that the customer had. And I think there's another quite interesting part of product selection here. So we identified actually that we could basically give the customer a much more cost-effective solution if our inverter that we had chosen could just do a little bit more phase current. So we kind of worked internally with the hardware team and then actually took on the validation testing ourselves in order to just test under safe conditions if we could just kind of push the boundary a little bit. And we actually found that getting around about 15% more current, we were able to get the acceleration requirements kind of nailed for the customer at the same time as keeping the hardware team happy that the additional current hadn't adversely affected the kind of lifetime of the product. So that's a kind of another, I would say that kind of falls maybe into the kind of customization part, but you know, on occasion, standard off-the-shelf product doesn't always fit the bill for a customer, and you know, the applications team can kind of really help sort of navigate between, you know, what the customer really needs and what the product can do. And we've got a pretty good result on that particular application. Next slide, please, Laurie. Yeah, so a couple of different sort of examples here, but sort of first, product integration broken into three steps. So design integration support, that's where the applications team kind of tries to understand the full system and where our product offer kind of fits in to that. And then we'll possibly do some remote integration support, and that might be kind of working with the customer on a call, going through maybe some ambiguities that they're seeing in the collateral in order to, you know, to set things up. And then hopefully that will kind of culminate in a system design review where we can sort of sign off on our offer fitting into the customer's kind of higher level plan with a reasonable amount of success. So yeah, a couple of examples here. Again, on the customization side, we had a customer as a diesel hybrid application in the marine space. They had a particularly challenging interfacing set of details that didn't really map onto our standard motor product. So we kind of really helped the customer link up with our mechanical engineering team to come up with a custom shaft, custom flange to get that kind of mechanically integrated. Second example was a fan drive, which was pretty massive, was I think 1.5 meter diameter, about 3,000 RPM kind of nominal speed. Any imbalances on a system like that were going to place you know, an exorbitant amount of unwanted force on the shaft of the motor. And we were able to work with the customer to help them design a face-mounted support for that. And then quick sort of example that's not on the sheet here, but I'm just going to throw it in there because it's kind of my background. Something I've worked on quite recently was we were doing some commissioning work. Customer reported that they were getting some vibrations in the vehicle at low speed. Applications team were able to go on site, use an accelerometer kit to kind of get a good frequency signature of the vibration, understand exactly what was going on. We identified that it was actually the way the customer had rigidly mounted the components in the vehicle. Our power electronics has some nice features in terms of driveline compensation. We were able to use the data that we got from the accelerometers to tune the filtering and the drivetrain compensator, and we actually got a really great result there. Also had some kind of slack or some torsional kind of wind-up effects in the drivetrain, and we were able to invoke our elegantly named anti-clunk mechanism, which basically allows us to have a lower torque ramp rate up until a very low torque threshold to kind of wind the system up very slowly, and we ended up with a really smooth vehicle as a result. Next slide, please, Laurie. Yeah, so product commissioning. I think product integration and product commissioning are kind of merge into each other a little bit, and for the purposes of you know, our process and the way we talk, certainly internally at Turntide, I've kind of came up with my own really my own definition for that. And really what I mean by commissioning is kind of physical installation and kind of dotting all the I's and crossing the T's on the vehicle, making sure everything plugs in, everything works, every customer's sort of happy. So we've done a product commissioning round very recently on a high performance two-wheel application that involved our lead applications engineer going out with a clear set of kind of pass-fail criteria in terms of really looking back to the initial requirements. Done a little bit of fine-tuning on site. Actually, customer was actually already happy, but we kind of looked at a few things. So the hill hold feature maybe wasn't fully optimal, and we had the opportunity to actually sit on the vehicle and actually feel the issues. And I think that's a really valuable part of commissioning, is actually going out and getting your hands actually on the application. There's something that you get there that's over and above anything that can be sort of codified in data and an email account of an issue. So yeah, go and getting your hands on and kind of having that sort of on the ground confidence that the vehicle's kind of working as expected. And yeah, we were able to validate all of the requirements that the customer had, and yeah, again got a pretty good result. Next slide, please, Laurie. Yeah, so in service support, I'd say if the applications team is doing its job right, I would kind of say applications issues there is a vanishingly small chance that you'll get an applications issue. Obviously, quality and product issues are to a certain extent expected and do crop up from time to time. But just to kind of look back to that, that building of confidence, if you get them 3 stages nailed, in my experience, you just don't see any applications issues. They should really be identified at that final commissioning stage, at the very latest. So yeah, in terms of in-service support, it's really about giving that ongoing support to customers. And yeah, so the 2 examples I've chosen here are, so the first one was an issue resolution where we had a failed inverter in the field. We've done some investigations. We've got a kind of 7-step issue resolution process at Turntide that we leverage for customer issues. It's kind of along the lines of 8D, a little bit simpler, so we can kind of do that a little bit more rapidly. And what we identified through kind of working with the customer actually was that the short circuit current of the machine that they had used, it wasn't a Turntide machine, but they had paired that with a Turntide piece of power electronics. So basically the vehicle had failed, and the inverter had gone into active short circuit, which is a kind of failure mode. And what we found later was actually the short circuit current of the motor was higher than the rated current of the inverter, which resulted in an inverter failure. So we identified maybe a small gap in our process there, and we've kind of built that in now to our critical information survey questions that we ask on the front end to just be absolutely sure what the short circuit current is if a third-party machine is being coupled with one of our drives. And then lastly, the applications team can be the interface for change requests for customers, whether that's feature enhancement and that sort of thing. And quite recently, we worked with a customer who we've been working with for a number of years, who wanted to change the DC link voltage on their system. I won't go too much into the technicalities, but when you increase the DC link voltage, the switching losses increase. So when you're delivering full power, your IGBTs or your MOSFETs, your switches are going to get a bit hotter. So we were, within the apps team, able to make a representative system in our dyno lab and do some validation testing for the customer to kind of show that this increased DC link voltage still allowed us to deliver the full kind of system power for the required 10 seconds. And then we worked with our engineering team to make some kind of minor tweaks to our switching frequency derate algorithm to ensure that could work. Yeah, so that's the last of my examples. Final slide, please. So yeah, I've rattled through zillions of concepts and ideas and philosophies there, so I thought it was a good idea to just be pretty explicit about kind of what I'm saying. So why a strong applications engineering team really matters, better engineering decisions, earlier identification of risk, fewer integration and deployment issues, faster issue resolution, and ultimately the ultimate goal, greater confidence and a higher probability of success in your application. That's the last of my slides. Thank you very much.
Yes, I'm going to stop sharing and see if we have any questions. What do you think is the things that customers come to you with that they don't think they need to have, but they should have and should be able to tell you? That's always a question I have heard asked.
Yeah, sure. One that just jumps to mind straight away is really all of the things along the lines of that operating environment that I referred to earlier. Thermals is one of them. When you look at an inverter specification, there's a very precise set of sort of test constraints that specification sits against, and that might be inlet temperature of the coolant system, the DC link voltage, the switching frequency, and it has been known that customers think that you can do whatever you like in the real world and it will always hit those numbers. So I think we've got the analysis of those effects and those interfaces really nailed in our process, in that the engineers are explicitly required to ask those questions. What is the ambient temperature? What's the flow rate of the coolant system? What vibration standard are you working to? So all of that sort of stuff, Laurie. Yeah, operational environment, and I could talk for ages. Driveline compensation, how you actually mount the components is massive. How well sprung that is. If you've got any dampening on rotating parts. So yeah, all of those things that sit outside of really that core question of voltage, current, torque, speed, power, all the basic stuff.
Great. Well, that was our only question. So I want to thank you again, Johnny, for that great presentation. I want to thank our attendees for joining us today. And this webinar, again, will be available on demand in about 48 hours. And remember to take a moment to register for the August webinar, which is in the chat link. And I hope you all have a great rest of the day. Thanks again.
Thank you very much.